Hello and welcome to another lecture for our CIT 130 Beginning Java class. Today we're going to delve a little deeper into our data types. We're going to look both at numeric data types a little more as well as strings. Now, while string is not one of our primitive types, it is an important type in all application development programming in general, not just in Java, but in other languages. In some languages, strings do appear as a standard or primitive type, but in Java, they have chosen to deal with them as what we call a reference type or objects of a class. We're going to delve very deeply into objects and classes in the second half of this course, but we're going to dig a little bit deeper into strings today. And that's where I'm going to start. So as I said, strings are not a primitive type. If you remember from an earlier lecture, we have a set of primitive types in Java, which include our byte, or 8-bit integers, our short, 16-bit integers, our int, 32-bit integers, and our long 64-bit integers. We have our float and our double. And these are our floating point numeric types. And then we have something called a char, which we're going to talk a lot more in detail about, and the Boolean. We kind of delved a lot more into the Boolean type last time when we started talking about the last two lectures, when we started talking about decision statements and loops or iterations. Both of those things depended upon truth values, whether some comparison or something to that nature was true or false was an important part of determining decisions. So that's where we delved a little more into the Boolean type. Today we're gonna start by talking a little more about the char because strings are built off of that. A string, more formally defined than we've talked about it previously, is a set of Unicode characters strung together. That's where we get the term string from. When we take a set of Unicode characters, the kind of characters we can type on the keyboard, along with a lot of other special symbols that can appear in text documents. The term we may be more familiar with is ASCII. Technically, ASCII is a subset of Unicode. Unicode is just a more global or universal set of reproducible characters in a standard text-based interface. And when we string those together, append those characters, we create sets of those characters that we call strings. When we make words and sentences and things like that that we're going to display in an application, those are strings. Now, from your introduction to programming, you should have some familiarity with the concept of an array. We're going to talk a lot more about arrays in the near future, but for now, let's just understand that a string is actually an array of char or characters. Technically, a char is a numeric type where the the number value is the Unicode value for that character. Characters within the Unicode set are represented by a numeric value, and that numeric value is used to represent to the operating system what symbol to display. So if we look at a Unicode chart, what we see is that our typable symbols, things like an exclamation point, correspond to a specific ASCII value, and that value in decimal is 33. So these numeric values, like the 33, is a number that corresponds to a standard created that identifies that number as meaning that symbol. And the operating systems like Windows and Linux and your Mac OS, those operating systems are defined to understand this Unicode character set. So that's why we say that these are numeric values. So when we string those numeric values that are associated with characters in the Unicode set, we string those together, we wind up with a string. When we work with characters or char literals, we deal with those using single quotes. So what we can do is we can put a single quote and a letter like a capital A, and that is Unicode 65. I believe it is 65. Capital A is indeed 65, which is a capital letter A. Similarly, we could say question mark, which is Unicode 63, is a question mark. String literals, and strings are the only reference type that truly have literals, are done with the double quote. So if I said, "Are you there?" that is a set of several letters, spaces, and a question mark in a character array. And that literal is assigned to a variable just like any of our primitive types are. So what we've done is, or what we do when we create a new string, is we create a character array that holds several characters, which we can call a string, and deal with it as a single unit. And we're going to play around with that a little bit in our um, examples today. And what we're going to do is we're going to open the non-deterministic version of our movie tickets program, where we were doing this loop based on whether they needed more tickets. One of the things that may have occurred to you when we were working on this version of the program is that this is pretty specific. This, whether or not the string is a single letter capital Y. Now, from an interface standpoint, what we might do here is we might say Y/N and and have that indicate what we want them to put in. But one of the things that we could do to allow the user to enter in a variety of different things that count as an affirmative is we could do something like this. We could say, we could create a variable, and if you remember, we generally like to create our variables at the top. So I'm going to make a char variable called yn, just to mean yes, no. And what I'm going to do is I'm going to do something kind of new. I'm going to do yn equals more dot char at 0. So what is this? What have I just done? So the first thing I want to say is, since strings are objects of the string class, we can call methods on them. Now we're going to go into much more detail on methods in the next lecture, but we've talked a little bit about them, and up to this point we should hopefully understand at least that a method is a set or a block of code that runs when it's called. We call methods, and then the code within them executes. We can only do that with classes and objects made from classes. And objects, the brief version that we're going to do before the midterm here are just variables where the what's assigned to them are things made from the class, which at this point we've done the scanner, so this keyboard is an object, and then strings like more is an object. And we can use things like methods on them, which we've already done. When we do keyboard.nextInt, we are calling the nextInt method on keyboard. We're going to go into methods much more in detail next lecture when we make our own. So that'll be kind of cool. So since we have that opportunity to call methods, we have the opportunity to go out and see what those are. So I already have the string class up in our API documentation, and we see that the class string has a number of methods, and one of the ones that we have is char at, and you'll see that it takes an int index. Now going back and thinking about an array, that really an array, for those just as a reminder, again, we'll be going over that soon in this course, is just a series of values held in a list. That list has indexes or addresses for each of the values. The addresses start at 0 and then end at the length of the array -1. So if they typed in YES, the indexes are 0, 1, and 2, because yes is a 3-letter word. So whenever we use char at 0, what we are actually doing is we are pulling the very first character off of the word or the string. So now what we can do is let's change this from more dot equals to yn equals y or yn equals y. This will allow them to put in yes with a capital Y, yes with a lowercase y, yep, yeah, you betcha, all of the above. So what we're doing is we're pulling the string off the keyboard, and then we're just looking at that first character so that whether the person kind of pays attention to this or not, if they do anything with an affirmative that starts with a Y, we'll loop again. So let's go out and show that that works. We'll do Java C movie tickets.java compiles Java movie tickets. So it comes up, because we're using the do while loop, the post condition comes up and asks for the first age. We'll go ahead and put in 7. Do you need any more tickets? So if I follow the directions, I type in the Y, and that comes in, how old is the person for this ticket? I go ahead and put in that edge value, the 12. Do I want any more tickets? Let's say I'm lazy, I don't want to hold down the shift. I hit Y, because I was asking if it was capital or lowercase y. I hit that. Should have worked. I put in the next age, and let's just say I'm feeling a little silly, so I go, yep. It asks for the next one. I put in that put in the next one, and I say, yes, sir. Now it has crapped out on me. We may wonder, so what's going on here? We're going to dig in a little deeper to our into our scanner. Now, one of the things, just like when we were talking about the parts of a program way long ago, and we talked about there being these tokens or these pieces of the program that build it up, when we pull data off the keyboard, that works in a very similar way. We take tokens off the keyboard. So going back to our notes page, the way it actually works is when I type in my age, what I really do is I type in the age and then I hit return. So it puts in that \n that we talked about when we first did prints and print lines, and that \n sort of works as the line terminator and indicates to the scanner that I'm done with that token. So I put in the 7, and then I put in the next token, like the Y. And when I do the next, it grabs that as a string. Next grabs as a string. And then I do the \n. Similarly, it treats that \n as the terminator for the token. But when I got to yes, comma, sir, we did something new. The \n, which indicated to the scanner that I was done, and it does end the token for sir, but the space in here is treated as the end of a token yes, comma. So what I've done actually is I've entered in what could be interpreted as 1 or 2 strings. So inside of the scanner class, let's go look at that, we find two different string methods. We have one that is next and finds and returns the next complete token from this scanner. And it returns it as a string. When, if we look down a little further and we see one called next line, it advances the scanner past the current line and returns the input that was skipped. And what they mean by skipped is advanced past. So because the space works as that token separator, then it saw this as 2 strings and it got confused. So what I can do is instead, oops, closed everything. Let me go back in here. What I can do instead for movie tickets is change this to next line. And let's see how that works. Let's go ahead and compile. And we'll run it. How old is this person? 7. Uh-oh. We ran into another problem. Brian, what are you doing to us? Let's look back at our notes. So what happens, or what's happening here, is when I type in the 7 and the enter key, it takes the 7 as an integer and it assigns it to the age. It did all these comparisons, added into the price. Then it printed out this here, but the way next line works is it advances to the end of the current line, including the enter key, and returns that. The problem there is that what we're returning now is just the \n. So we're in kind of a conundrum. If I want the person to be able to enter in something longer than a string that contains spaces, I have to use next line. But if I want to go between strings with spaces and things that don't contain those spaces, what I need to do is add a little trick in here. When I take the int I can add a new line that says keyboard dot next line. You notice I am not assigning that to a variable. What I'm doing is clearing the scanner buffer, clearing the input stream, clearing the string of that enter key. So now what I did was when I got the 7 as an int and threw away the \n. Then when I go to the y, it'll be a full get string. So I'll get the whole thing and check the y. And then all the other stuff and the yes sir will work. So let's go back and look at that. So what I've done here is by adding this, I'm clearing that keyboard buffer. I'm eating any leftover \n's that are in there so that I can move on and grab the next one as a complete line. Let's verify that that gives us a final solution here. We'll go up, we'll compile again, and we'll run again. 7, capital Y, 12, lowercase y, 49, yep, 55, whoops, yes sir, 77, you betcha, and 33, I think that's what we've been doing in our examples. When we're done, we can just say no. We get that total cost of 41 that we were getting in the previous lecture. Before we move on, I do want to talk about one other thing that may or may not have jumped out at you. When we were doing this as a string comparison, we did while more dot equals y. So there's a couple things going on here. The first is you may have noticed this is sort of new. One of the things that we do in Java is the equal sign, the symbol that we're used to pronouncing as equals, is the assignment operator. You may not have noticed, but in past lectures I've referred to it that way intentionally a few times. In order to differentiate between assignment and checking for equality, is the double equals is checking for equality, where the single equals is an assignment operator. One of the things that is important about that is if we accidentally put in a single equal sign, I'm going to comment that out so it'll compile. Let me show you what that does. Let's compile it. It says bad operand types for binary operator OR. And then it says incompatible types, char cannot be converted to Boolean. So we get these weird errors because basically what I'm doing is I'm saying, instead of saying check if yn has the value character capital Y, what I'm saying is, assign the value capital Y to that yn. So you don't want to do that. You want to do the double equals. Now the second thing that is probably the bigger thing that jumped out to you is here I used the double equals, and here I used dot equals. When we deal with reference types, which variables that are of classes, objects from classes, what we are really, how we want to compare those is using this dot equals method. For now, just understand that when this is not a primitive type, is a variable of a class type like keyboard or more, scanners and strings, which are the two we've worked with so far, we need to use the dot equals, which is a method of comparing the two, as opposed to the double equals. When we do the object-oriented stuff after the midterm, that's when you'll really dig in, you'll really understand why this works that way. We'll really talk about what the difference is, but for now, just understand that with strings, we use the dot equals, and with primitive types, which char is a primitive type. Remember, we just talked about that, reiterated that today. We use the double equals. So now what we've done is we've looked at some extra stuff here with the characters and with strings, and we're gonna go even more into that in a few minutes, but let's look at something else in here. I hinted at this with you previously, but I want to talk about it again now. So when we put in this, the dollar sign here, the dollar sign here, and we put this little +0, we were only able to do that because our prices were all like either, or they all ended in a 50-cent range. But let's say that instead of $5.50, we changed the value here to $5.75. Let's see what happens now. Go ahead, do the same example we've been doing. Clear that. We'll compile. Oops. And we'll 7, yes. 12, yes. 49, yes. 55, yes. 77, yep, and 33. No, we don't need any more tickets. Now it says 41.250. Things got messy because the 75 for the 7-year-old added to the 50s here wound up putting it 25 cents over, and now that little 0 there didn't work. But it did work when I had it as 50 cents. But there's got to be a way to make it work regardless so that I don't have to worry about that piece of it. And there is. There is another version of the print. We've worked with print itself, which doesn't add the carriage return. And we've worked with print line, which does add the carriage return. Now we're going to work with printf, which is a formatted print. So what I can do is I can say the total cost of your ticket is $. We're going to put in comma price. Bear with me as I delete that. And what I'm going to do here is I'm going to do %F. So this looks kind of weird. Remember we talked about those escape characters like our \n and our \t. In printfs, we have these formatting sequences that tell it that we mean to substitute the % thing with something after the string. So we have a second argument, which is the variable. So instead of appending it, what we're doing is we're substituting it for the formatting symbol in here. Why we use %F is that indicates that we're going to substitute in something as a floating point number. Let's see that as its base. What does that look like? Because we're not done. But let's take a look at it. We'll compile it and we'll run it. I'm going to do less ages this time because we don't need to see the whole thing. And let's just do the 2. And you'll see it's 13.250000. Well, that's not any better than what I had before. Well, that's because I just told it to print it as a floating point number in general. I can actually specify more information inside this symbol by before it using some kind of width and or precision. So let's go up here and put in a width and a precision. So what we've done by 5.2 here is we're saying we want the entire floating point number to take up 5 characters in width, but go 2 places past the decimal point. So what we've done is we've said 5 as a whole, including the decimal point, but 2 past the decimal point. Let's see what that looks like. We'll save that. We'll go back here. We'll recompile. We'll do our 7. Yes. We'll do our 12. No. And we get 13.25. But I want to look at something a little bit different. Let's say, let's run it again. And let's just say I was going to the movies by myself. So I don't need any more tickets. You'll notice, and it's subtle, that there's a space in between the 7 and the $sign. That's because I've indicated I want the width to be 5. So if my width is less than 5, it puts that space in there. The reason that's a thing is when we want numbers to line up, when we print them out on separate lines, it might be important for us to put to have numbers spaced out so that if, like, say the number 1325 was above 750, the decimal points would line up. So that may be a thing we'd want to do. Well, the good thing about the width is it won't truncate things off the front. So if you need more than the 5 characters, it would add them. So if we just want it to print nicely every time because we're not lining things up, we can just get rid of that width and have only the precision. Because what that'll do is it'll always butt the number up to the $sign regardless of how wide it is. So if I save it again, I compile again, I put in my 49 and no, that looks nice. I run it again with the 7, yes, 12, no, and I get the 1325. So it looks good both ways. We're gonna look a little more at printf more as we go through today's lecture. So hang in there, and we'll show a little bit more. For now, we're just using it for that part. So to dig a little deeper into strings, what I am going to do is I am going to ask another question. So what I'm going to do is up at the above the loop is I am going to ask the user, would you like to give us an email for sending you promotions? Actually, just to make it simpler, I'm going to actually say, please enter an email for sending you promotions. I just don't want to add the extra in if they say yes versus no. You can play with that on your own. When you download this example, that's actually a really nice exercise for you to make sure you're getting everything here. Similar, we could just use like an if statement version of what you see down here with the Y and the N and taking the character off the front. Be a great way to practice that and play with it. Here, I'm just going to assume they want it. We are going to need a string to hold that email, so let's declare it. And we can separate, I may not have mentioned this in the fact that I've done it. Sometimes as an experienced developer, I can forget some of the simple things to explain them, but the comma separating variables is a way to concisely declare more than one variable of the same type on the same line. Sort of what I did down here. I declared price with an initial value, total cost with an initial value, separated it with the comma. Just doing the same here. And now what I can do is I can say email equals keyboard.next, and we'll make it the standard next because people shouldn't have spaces in their email address. And then what I can do is I can use a different method from strings on this here. So what I'm going to do is I'm going to say if email dot contains at, and we'll talk about what that means in a minute. And then in the front of that, I'm going to put this exclamation point for the not. This is something we talked about briefly during the decisions lecture, but now we're seeing it in action. Every time we work on these examples, every time we do a new application, we have a new opportunity to try something that's a little bit different than what we have tried before. So what I'm really saying there is let's look at the contains first, and then I'll explain the not. Let's do this in 2 steps. So if we go back to java.lang, we look at the string, and we go down and check out the methods that are involved with it. You'll see that there is one called contains, and it says it's a character sequence that is can be represented as a string. And so we're just doing one that's 1 in length. Doesn't matter. It could be a longer sequence than that. But it's just a sequence of 1 @ symbol, just to make sure it's a valid email. What we can do there, so what we're doing is we're saying if the string email contains the @ sign, then it's valid. But we only want to have a problem if it's the opposite of that. This is one of those times where if it doesn't contain that is when we have a problem. So we only want to print out a message to them to tell them there's a problem if they didn't put an @ sign in the string. So the only way we can express that is by saying, I want the opposite of this. This, when this is true, I want the whole thing to be false, because I don't want it to print the message. So when there is an @ symbol, I don't want the message. So I say, give me the opposite. That means if it does not contain that symbol, containing the symbol is false. When I take the not, I'm taking the opposite. I'm flipping that false value to true, and then I'll print out the error and say all email addresses must contain an @ symbol. And one of the things we're going to want to do here is make this a precondition loop. While, not email.contains @ right? That way, what we're doing is if it doesn't contain an @ tell them so and try again. So let's save it. Let's recompile. Oh, I left out a semicolon. That is so easy to do. And I left out a parenthesis. That's even easier to do. One of the things that I like about doing these lectures live and showing you my compiler errors, that's not because I like to be embarrassed, but I like to show you these common errors. So you see the highlighted part here, that is that goes together, not email.contains at, but there's no closing parenthesis for the while. So leaving that, you seeing me make that mistake, or you seeing me leaving out the semicolon, that is a lesson. That's a thing you can see and go, oh, these are the kinds of things that are really easy for any person who does this kind of development to do. Now it compiles. We go ahead and run it, and it says, please enter an email for sending your promotions. And I'll type in brian.borgon@csn.edu. But let's say I just wasn't thinking, and I said brian.borgon.csn.edu. And then I hit enter. It says all email addresses must contain an @ symbol. Please enter. Oh, that's right. I don't know what I was thinking. csn.edu. Now what it's done is it's taken that address in. I type in my age. I don't want any more tickets. I pay $7.50, and we are ready to go. So this is really, again, it reiterates that what's cool about strings being a reference type or a non-primitive type is we can call these methods or these sections of code that allow us to do stuff with or on that this object. Again, we'll talk more about methods next time, and we'll talk a lot more about objects, classes, and that stuff in the second half of this course. But in this case, what's really cool is we've just seen another way of looking at this and of using it. So that kind of covers the part that I wanted to do for strings and characters. Now I want to move on to another section that is about our numeric types. I want to delve a little bit deeper into our numeric types because there's some other cool things we can do in there, and there's some other things about the Java programming language I want to go over about our numeric types. So let's talk about that now. So how we're going to start looking at numerics now is through a new operator. Now we've all been familiar up to this point in our programming and our mathematical careers with the plus, the minus, the multiplication, and the division. But there's another mathematical operator called modulo or modulus, which is indicated by the percentage sign. Now, to some degree, this is something that you encountered back when you first learned division in elementary school. When I do something like 13 divided by 2, when we do the integer division, something we have already talked about, we get the answer of 6. If we do it as floating point division, 13.0 divided by 2.0, we get 6.5. But when we were in elementary school, we learned this as 6 remainder 1. When we do 13 mod 2, the answer we get is that remainder. It's the 1. So how we say that is we say 13 mod 2 is 1. And it may occur to you, or you may be thinking, great, but what would I use that for? I'm going to show you a really cool way that can be used. Let's go back to our example. And let's just say the movie theater that this is for, does some sort of fun promotions, ways to shake up the cost that's fun for people who come, and adds a little spice to the program. So what we're going to do is we're going to, after they have gotten their price based on their age, what I'm going to do is we're going to say that this movie theater has something called the 11 Club. That if your age is 11 or 22 or 33 or any multiple of 11, you get a 50-cent per ticket discount. Just because it's something they've decided, is fun. So what we would do is we would say, if age mod 11 equals, remember double equals, that's comparison 0. Because one of the things the modulus operator allows us to do is check if any number is divisible by a different number. Because the way it works is this. 1 mod 11 is 1. 2 mod 11 is 2. Because 11 goes into 2 0 times with a 2 remainder. 3 mod 11 is 3, and so on, until we get to 11 mod 11. That's 0, because 11 goes into 11 one time with no remainder. Here's that, but what's really cool, another property of this modulo operator is the pattern repeats. When I do 13 mod 11, it's 2, because 11 goes into 13 once with a remainder of 2. So what we see is it continues to have a repeating pattern. This yields 2 other uses, not that we're using at this point, but 2 other uses of the modulo operator, which is maintaining a range for a numeric value. How that is whenever we have x mod y, that will be a number between 0 and y minus 1. What we're talking about here is no matter what x is, when we modulo or mod it by y, that number will be between 0 and y minus 1. So if no matter what x is, if y was 7, the only result would be 0 through 7. It's a really great way to guarantee that no matter what number somebody enters, that we can bound the output. We can give it a ceiling value. And kind of along with that is in loops or iterations, particularly in for loops, we can also use it. We can use that bounding along with the repetitive pattern of it to loop over the same set of numbers repeatedly. So, like, let's say you had a queue program, a queuing program, where people were assigned a number, like, oh, you're number 77, you're at the deli and you're waiting for your number to get called, using, but let's say that the ticket counter resets at 100, so that, your count from 0 all the way through 99, and then you want to start issuing the lowest number again, because you don't want 6 months from now you to be calling 10,452 to be the next customer. You know that you've handled all the earlier people. You can just loop over that same set of numbers repeatedly in that situation. But in this case, what we're doing is we're determining if one number is divisible by the other number. Very valuable thing to be able to determine. So what we've done here is we've determined that we're determining that if their age is divisible by evenly divisible by 11, meaning there's no remainder, what we can do then is we can say price minus equals 0.5. Give them a 50-cent discount. That's, it's not uber practical in terms of like this program. It may feel like, oh, that's kind of a silly example, but the value here is we're seeing how this fits in with the whole thing, and it works with the example. So that modulo operator, it's very, very valuable, and it's important to keep in mind. Another thing I want to talk about with in terms of numeric calculations is something called the math API library. If we go back to our java.lang, which we're in right now, you'll see that there's this class here called math. The math class gives us a number of mathematical operations that don't fit into that simple calculation like addition, subtraction, multiplication, division, modulus, where like our trigonometric functions, our sines and cosines, tangents, some things like exponential math, where we do powers of things, pow, double A, and double B, which takes A raised to the B power. And one that I wanted to look at right now, just as an example of using this, it's really all I'm talking about, is the round, where it will return the closest long to the argument, where the argument is a double, with ties rounding to positive infinity, which just means that ties round up. That's a fancy way of putting that. So, where might we use that? What we'll do there is discounts taken into account. We could say if math.round price equals price, let's make it does not equal price, meaning that if we round, which in this case is always going to be up, because 50 will round up, 75 will round up. If their ticket price isn't a round number, so again, this is mathematical thinking. You've probably heard before, programming is a mathematical subject. What we're doing from a logic standpoint is we're saying if we round off the number to the nearest whole number and it stays the same, that means it's already a whole number. That's the check we're doing. And if it's not that, this comparator, we've done less than, equal to, greater than, equal to, equal to. There's also not equal to, which just uses the not and the equals. We can say system.out.print. Would you like to round your ticket price up to donate to charity? Pick your favorite charity. You can, do whatever. And then what we could do is we have the yes, no, and we aren't using it for this lower part yet, so we can use it now. And here's a great extra lesson that I can throw in here. You notice that yes, no is here. It is within the main method and declared at this point, which means from that point all the way to the end of the main method, that variable is what we call in scope, and we can use it. So the part that I'm working on right here is in scope. So what I can do is I can assign it a value. It will get replaced down below here. Whoops, I want to put more, not yes, no, but if I pull up, you'll see more and yes, no essentially have the same scope. What we'll do here is we'll say more equals keyboard dot next line. And in fact, I can do the same thing again, and then we can say yes, no, equals more dot char at 0, which will give us the first letter off of that, And now we can say if yn equals y, or yn equals lowercase y. Another opportunity to see that same thing. Now, here's a great example of something I mentioned in the last lecture. If and while work very similarly. The difference is if is only checking once to see if I've performed what's in here once or not. The while will check at least once, but if it evaluates to true, it will loop back around and perform again and then check again. That's the difference between the if and the while, but they use the same logic structure. In this case, if it's an uppercase y or if it's a lowercase y, we're going to do something. And in this case, we'll say price equals, or is assigned, round price. So we'll round off the price, math.round. We have to make a reference to round, or we have to tell it where round is, which is inside the math class, and then perform that operation, assign it back to price. So let's look at this with these two options in here. We'll compile again. Oh, I made a mistake. Again, very easy to do. Accidentally put a single equals where a double equals is appropriate. Let's run it. Let's put in that email. How old is the person for this ticket? Let's just say, let's do the 55. Do I need any more tickets? Yes. This one is for someone who is 49. And you'll see it's asking about the charity. The 55, that person would have been charged $6.50. The 49-year-old would have been charged the $7.50, which is a total of $14. But because we got the discount for being in the 11 club, it dropped that price to $13.50, and what we are now, so we are now being asked, because $13.50 rounds to 14, and 14 is not equal to $13.50. So if we say yes, it will round it up and we'll pay $14 for everything. One thing that is probably a good idea to do is, in this case, it didn't let us know about that, about the 11 club. So we might want to throw something in here that says, congratulations, you are a member of the 11 club. You get a 50-cent discount. So we'll just throw that in there. So that's kind of cool. So So that shows a couple of more mathematical operations. So now I want to talk one more thing about numerical values. If we go back here, we have our numeric types, and I'm going to specifically focus on the numeric types that we use as numbers. You may remember that a byte is 8 bits, a short is 16 bits, an int is 32 bits, a long is 64 bits, a float is 32 bits, and a double is 64 bits. So all our numeric types are no more than 64 bits in length, or 8 bytes. And I mentioned this very briefly in passing, but integers, which are the first 4, store as 1 bit for sign, positive or negative, the rest for the value. With floating point numbers, we have 1 bit for sign, and then floating points are stored in an exponential notation, which is some number raised to another power, because we don't want to represent the decimal point like as a car or something like that. So what I mean is everything is stored as like 2.3 times 10 to some power, and I'm just using this caret in this case just to represent. We know that's exclusive OR, but let's just say to the 5th power, that it would store that as 23 in the base, and then 5 as the exponent. We call that first part a mantissa, and the second part the precision or exponent. And that there takes up the mantissa is 23 bits for floats and 52 bits for doubles. Sorry, we'll say bit because it's a 23 or 52-bit mantissa, which leaves us with an 8-bit exponent or an 11-bit exponent. The reason that's important, the reason I'm bringing it up, isn't just so you can be good at like Jeopardy, but it helps us understand, first of all, why there's a difference between integers and floating points. They're fundamentally stored differently in the computer. And then it's going to help us understand an important concept we have inside of Java, which is promotion. When we work down this chain here, going from byte towards double, we can automatically promote. Values going that direction. When we go the other direction, we can't automatically demote. What we have to do is we have to cast, and in that case, we only do it when we're certain that that is going to serve us well. Must cast to demote. So let's look at it in an example, and hopefully that will clarify a little bit what I'm talking about. So age, we've made it an integer. When since it's an integer, what we can do is we can get that age from the keyboard. We could pull that in as a byte. So what we would be doing is taking the number off the keyboard as a byte, or an 8-bit integer. 8-bit integers can go only as high as 127, and so we might do that because, like, oh, nobody's going to be over 127 years old, and it'll prevent us from them accidentally typing in some age way older than that. So that might be a good thing. But because of automatic promotion, we can go from byte down or promote to integer automatically. With doing nothing else on this line, that byte can store in a variable of type int. That is automatic promotion of the value. If I just do nothing but that, change it from next int to next byte, we'll see the program doesn't change any. So we'll put in the email. Oop. Showing my putting in my Gmail address, which you guys know from the YouTube channel. How old is the first person? 55. We need another ticket. Now you see the congratulations, so we know we're going to get that 50-cent discount. I put in the next one. I say no. This time I didn't round it up, so it'll be $13.50. And I say no. And we see the program worked the same. The point there is that this next byte didn't cause any problems. If instead of doing it that way, and I still wanted to leverage that idea that a byte can only go to 128, and I make the variable a byte, but down here, I had left this as next in, then I can save it, and we'll see we have a problem. Because now we're pulling the number in as an int. Next int will take whatever's on the keyboard and it will hold it as an int. In theory, even if they put in something like 7 or 49, which is a valid value for a byte, it's being stored in something that's 32 bits, which can hold numbers much, much larger. A byte can only go up to 127, where an integer, I think it's like 2.1 billion. So the program, much like when I was talking about when we were doing sort of our conditional statements, and we talked about the compiler wasn't smart enough to know that one of the conditions would be true, since any of them could be false. It said, there might be a problem here. In this case, it's similar. Even though we may type something in that is much smaller, it doesn't know what we're going to type in. So it is going to have a problem letting us force that into a byte. It's like if we got something in the mail that came in a box that was, say, 8 cubic feet, and we wanted to take whatever it was in it and put it in a box that's 1 cubic foot, we may or may not be able to do that. The box is smaller, so there may be something in the bigger box that doesn't fit in the smaller box. So when we take this in from the keyboard, it may be too big to fit in the little age box. So what we'll see when we do that and try to compile is we'll get an error that says incompatible types, possible lossy conversion from int to byte, which just means the number may be too big to fit in a byte box. So if I just let it happen, something bad could happen. So, but the language has given me the ability to do something to get around that. I can put the other data type inside parentheses in front of the operation. So what I've done is I've said take whatever's on the keyboard as an integer and put it in a byte box. By telling the compiler I want to do that, I'm telling it I accept the consequences. Usually you will cast when you know you're safe. In this particular instance, technically we don't know we're safe, but much later in the semester we're going to learn a way to deal with this where we can verify that we're safe. So in the short term, this is just sort of an experiment, or not an experiment, but like an example to show you demotion, taking something from the larger data type down to a smaller data type by using casting, just so you can see how that works. So let's recompile. I no longer get my error, and so now when I go through the process and I put in the 55-year-old, congratulations, yes, I need another ticket for the 49-year-old, I'm feeling generous. I have no more tickets, and the whole thing works properly because I did the casting. So just in the notes, just think of it as when I go from these this way, I'm essentially taking something from a small box and putting it into a bigger box. That always will work. The way this mantissa and exponential thing works allows these numbers to be much bigger than these numbers. So we just, that's why even longs will fit into floats, even though the bit style, the way the numbers are stored, allows it to kind of go the other direction. And for D motion, we have to use the cast. We have to put the data type in parentheses to tell it to kind of force its way, and that we as the programmers are willing to accept whatever consequences occur there. So there's one last thing I want to go over. I mentioned it very, very briefly in the lesson on decision statements. There's one other kind of decision statement that exists other than the if-else sort of structure and the trinary operator that we did, and that's called a switch statement. And I just want to show that briefly here. So let's say when we take the email, we're going to have them please enter a name for our promotions program. And we will add a name string. We can do name equals keyboard.next. And oops. System.hold on. Print. I want these prints, not print lines. Please enter an email for sending your promotions. I got extra stuff here. There we go. Oh, this and that. Okay. Think I've got it. And then what we're going to do is sort of as a part of our wacky promotions, let's say this. We might have something like if name.length, length is another string method that will tell us how many letters is in the name. If name.length is 10, I don't know why I put that there, we'll say discount equals 10%, which is 0.1. And we might say if name dot length is I don't know why I did that. Equals 10. And I'm going to take it one step further. I'm going to go greater than or equal to 10. Then they get 10%. If name.length, and it has to take a header format, is less than or equal to 9, then discount equals 12%. People with really short names get a discount because it's just part. Well, actually, let's say it's less than 9, and because I want to make this an interesting example, name.length is greater than 5. We'll do 12 if name dot length is less than or equal to 5. We'll do discount equals 11%. Just like I said, everything's kind of a wacky promotion scheme at this movie theater. It's become their element of fun. And so what I've done here is I've done a series of if, else ifs that are checking values. And actually, I do want this to be equal to 10. And in this case, if it's not that, then we'll make the discount equal to 9%. Doesn't matter. The point here is, oops, not 90%. Oh, shoot. 9%. We can write this idea in a different format. There's a syntax where we can say switch name dot length. Now, switch statements only work with character, string, byte, short, and int. So when we do a switch statement, we're basically saying, I want to do some tests on the value of this. And what we do is we do them in a series of cases. Cases are considered equality things. So when I say case 10, that means when name.length equals 10, discount equals 0.1. Case 9, discount equals 12. We'll come back in a minute or two for the 8, 7, and 6. Actually, you know what? I am going to just do it right now. We'll just say discount equals 12%. Case 987. Discount equals 0.12. Case 6, because 9, 8, 7, and 6 are in that range there. Because remember, this is an equality comparison, not a less than, greater than. When we do the next one, we're talking about 5 discount equals 11. And for the sake of saving us some time, I'm going to copy that. That'll be 4, 3, 2, and we'll just say 1. I can't imagine somebody who has a name that is 1 character. But just for the sake, again, of demonstration and learning, let's just look at it that way. Then for the else, we use this keyword default, and we just say discount equals 0.09. And just so we can see what it is this produced, we're going to add in a system.out.println. Sorry, I don't want to do a print line. I want to go back to our printf and say a name of %s has %d letters and gives you a discount of %.2f. %f, which stands for string, can be the name. The length of name is name.length. We can call that method as many times as we want, and it will return the integer value. And then here we can do, we can put discount. We've already talked about what the 0.2f means. It'll give us 2 places past the decimal point as our discount. That way we can just see that that's going to work. Now, I'm going to comment this section out because what we're doing is, what we're doing in the case statement is essentially, the switch statement is essentially the same thing. Let's just see how it works. And then we're going to come back because right now it's not going to work great. I missed a semicolon. One of the things you'll notice right here where this says Java :61, that is where it is finding the error. And you'll see my line numbers are over here. So as our programs get longer, you'll see that that's a valuable thing. So now we compile, and I made a mistake. I forgot to declare discount. You guys should have reminded me. I'm just kidding. This is a video, so you're not talking to me. Discount. Let's see if that takes care of all my errors. Oh, I misspelled it on one place. And what line was that? Line 45. So I go in here to line 45 and I type in discount. Now it works. Enter my name, Brian Borgon. I made a mistake. Let's look at that again. Oh, I know what I did wrong. I said name and then entered a full name. Let's just say it's first name. Just so we can use the next. I could have used next line here for the full name, but for the promotions program, we just want the first name because when we send the emails, we want to make them real personalized. So, it'll be Brian. Let's Control C will always cancel what you did or cancel the program so I don't have to fill in more stuff. Let's rerun it. Let's enter your first name, Brian. Brian.Morgan@csn.edu. And a name that of Brian has 5 letters and gives you a discount of 0.9. And then it says, how old is the person for this ticket? Ooh, that looks terrible. That looks ugly. So let's cancel it and let's look at what might cause that. So one of the things about our printf, which we have right here, is the printf works very similar to the print in that it does not put the carriage return in. In these cases, that's nice because what we're doing is having them type something in on the same line. But up here, here we want that enter in there. Now we could use the \n. That works because escape characters will work even in a printf. But we can also use a %n, and that's what most people will do because it's a printf and it understands these percent pieces. The %n is what we use most of the time in a printf to get that same functionality. Let's go ahead, compile it. Enter my first name, enter my email. You're getting used to seeing this. Now it looks nice. I get a 9% discount. How old is the person? They'll be 55. They're in the 11 club. I'm going to get another ticket, 49. Would I like to ramp it up? I do the yes and then the no. It says $14 because I didn't actually take the discount out. If I want to be complete here, what I would want to do is take the discount probably before we round. So let's just do price times equals 1 minus discount. Again, I want you guys thinking mathematically. A discount would be 100% or 1 minus the discount. So like in my case, it would be, I think it was a 9% discount. So I'd be paying 91% of the price. So multiply, of means multiply, 91% of the price there. One of the things that's interesting is now round could go either way, up or down. So how do we deal with that? If we go back to our math class, in addition to round, we'll see that we have another one called ceil. Returns the smallest, closest to negative infinity, just meaning lower bound, double value that is greater than or equal to the number passed in and is equal to a mathematical integer. All that means is round up. Sometimes the language is very precise. That is something that is pretty common in mathematics because particularly in arithmetic and number theory, imprecision can lead to wild results. So I'm just simplifying for you, and just understand that it is referring to the rounding up, that the ceil or ceiling, did I spell that right? I did, is always a round up. So let's save that. So let's go out here one more time and let's look at how it works. Put in my first name, put in my email address. I get a 9% discount. How old is the person? 55. It says that we have a 50-cent discount. Oops, I left a piece of debug code in there. That's okay. That tells us the price there. Would you like to round your ticket price up to donate for charity? Yes. Oh, I see that I have made a mistake that we didn't catch earlier. I'm going to go ahead and say no, and it's going to charge us the $6. Something that we made a mistake, or I made a mistake on earlier but didn't catch, is I'm doing this discount part in the wrong place. The reason I didn't catch it before was when I was getting that 50-cent discount for the 11 club, I was getting a price that was a round number, thus not asking me this question till the second time through the loop. I actually made an error. So I want to move that part there to outside the loop. I'm going to leave that comment where it's at, because when I comment this for uploading, you'll see some additional commenting there. So in this case, I caught what we call, a logic error in my program, which shows the importance of any of thorough testing. I just happened to been testing over and over with one example that didn't display my mistake, but you just saw it happen when I had a price that was different. This needs to come out too. What I found was that I was asking that question in the wrong place. So what I really want to do is this case statement sets the the switch statement sets the discount, and then this goes out here. Now, we're not quite done yet. I want to do one, I want to show that this works, but then we have just a little bit more in the switch statement to cover. Movie tickets.java. Movie tickets. Put in the name. Put in the email address. So we're going to get a 9% discount. The age of the first person was 55. Congratulations. You get a 50 discount. We need more tickets for a 49-year-old. We don't need any more tickets. We will round up for charity. And we wind up paying $13 complete for our ticket and our charitable donation. But one of the things I wanted to point out is my name, Brian, is 5. I got a 9% discount when I intended to get an 11% discount. What we're dealing with here is one of the things that is interesting about a case statement is this thing called a label with the colon. When it finds the first matching case label, it does it does every line of code after that. So what is customary to do is put in an extra statement called a break statement, which is an execution control statement. What the break statement does is it says exit the current block. Break out of the code block that I am in. I don't have to do it on the default because I'm done. So now it will give me the correct discount, which should be 11%. Let's just do that. Whoops. Now I have my 5-letter name. I'm getting an 11% discount plus my 50 cents off. And I don't need any more tickets. Yes. And I'm still paying $13 because of the round up, but I got the correct discount now. Now, one of the things you may be asking yourself right now is, boy, that if way of doing it looks a lot simpler. And it certainly, because we've seen it before, is somewhat similar. But there is some efficiencies we're missing here. One of the benefits of that label concept I just gave you is you see how 9, 8, 7, and 6 all yield that same discount. What I could, in theory, do is put these statements one after the other because they all yield the same result. So now, whether it's 9, 8, 7, or 6, it goes to that label and then continues to run till it hits the break. The same thing applies to the 5, 4, 3, 2, and 1, and then we have our default. Now it's a lot cleaner. And what you'll see frequently, because of the white space rule we've talked about before, is we'll often chain identical cases on the same line. Now, I try to keep trivial or unrealistic code examples to a minimum, but what we're looking at here is pretty rare. Ranges of numbers aren't super common in case statements, but when they're as well defined as these ones, and we get this nice concise switch statement that works exactly the same as these ifs down here, sometimes you will see that as the syntax. But the main thing I wanted to show you as I pared that down was the fact that cases that yield the same result can be chained in this way. And they can be on their own line or all on one line. This is one of those places where you'll often see it on one line because it's very, very neat and clean. So this lecture has been longer than the previous ones, and we did cover quite a bit here. But just to summarize, we talked about strings being class objects. We talked about string literals a little bit, the relationship between chars and strings. We talked about the methods, several of the methods like length, contains, char at, of the string. We went through the printf method, looked a little bit at formatting printed data. And then we also did some cool stuff with our numerics. We talked about the modulus operator. We talked about several functions or several methods of the math class that gave us the ability to do different kinds of mathematics. And then we finished up with the switch statement, which allows us to do sort of repetitive equality comparisons down through a particular decision structure. If you have any questions, please feel free to reach out to me. I encourage that. And otherwise, I look forward to talking with you soon, and you'll see a new video sometime within the next week. Take care. Bye-bye.